Hi everyone! So before I start the Chapter 7 lecture, I kind of want to give you a little preview or a little taste in terms of what you're going to be learning. So I'm actually going to be teaching you 3 different conversions that we actually use in chemistry quite often. So we're going to start off with something that you are familiar with, all right? So I'm going to write down a question. So in this first example, I want you to figure out how many seconds are in, let's say, 194 hours. Okay, so this is the question that I want you to solve. How many seconds are in 194 hours? So this is something that all of you should be able to do. So let's start off with the number that we're given, 194 hours. And we want to convert these into seconds. Okay? So I know that there are, sorry, not a 2. That's not where I want to begin. I know that in 1 hour, there are 60 minutes. Oops, oh my gosh, I'm having trouble spelling today. Okay, 60 minutes, right? 1 hour contains 60 minutes. And the reason why I put the hour here on the bottom, because I want the hours to cross out, right? So then I know that those hours will cancel out, and then so far that's going to leave me with my answer in minutes. But I don't want my answer in minutes, I want my answer in seconds. So I have one more step to do. Okay, now I'm going to convert the minutes into seconds. Well, I know that I have that there will be 1 minute, in 1 minute there will be 60 seconds. Okay, once again, notice that I put the minutes here on the bottom so that they will cancel out with those minutes there. So let's cross those out. All right, and then that should give me my answer in seconds. So let's go ahead and put that into our calculator. So 194, and then I'm going to multiply by 60 because this number's on top. So remember, when the number's on top, your calculator understands it as multiplication. And then I'm going to multiply by 60 again because that number is also on top. All right, so once again, start off with 194 times 60 times 60 again. So 194 times 60 and times 60 again. All right, so I got this really big number. Oops, go to my pen option. 698,400. All right, let me just double check my calculator to make sure that I got that correct. So 194 times 60 and then times 60 again. All right, so that is the number that I got, and that's in seconds. All right, so it's a really big number, and I will actually convert it into scientific notation because I only want my answer to contain 3 sig figs. Okay, 3 sig figs. So then to put that into scientific notation, then it would just be 6.98 times 10 to the, so let's see, 1, 2, 3, 4, 5, times 10 to the 5th, all right, and then seconds. All right, so that will leave me with my answer with the correct number of sig figs. Let's do one more example. So I'm just going to move this up out of the way. All right, so we're going to do another example. This next problem, so this will be sample problem number 2. Okay, so for this next question, let's do how many eggs are in 15 dozen? Okay, so how many eggs are in 15 dozen? All right, so we know that 1 dozen equals 12, right? All right, so we're going to start off with the number that's given. So start off with the 15 dozen. We're going to do the times. All right, so now we need to figure out which one of those numbers will go on top and which one will go on the bottom. All right, so we have to figure out, should I put the dozen here on the bottom or should I put it on top? And then I have to figure out, do the 12 eggs go on top or does that go on the bottom? All right, so if we start off with dozen here, then that means I want the dozen on the bottom so that my units cancel. So 1 dozen on the bottom equals 12, and I should put eggs here because that's what we're talking about. All right, so notice that dozen will cancel, and then all we have to do is multiply by 12. Okay, so you should put this in your calculator also. So 15 times 12, and I get 180 eggs. Okay, don't forget to check your answer and round it to the proper number sig figs. So there are 2 sig figs in 15, and if I leave my answer just as 180 with no decimal, that will also give me my correct number of sig figs of 2 for my answer. So I'll just leave it as 180 eggs. All right, so that is basically what chapter 7 is all about, conversions. And so these conversions were pretty easy for you to do because you are familiar with these conversions. So the chemistry conversions are going to be new to you. So at first it's going to seem challenging and difficult because they're new. But once you learn and practice the conversions, you'll get much better at them, and then you'll start to find that they're actually quite simple. Okay, so now I'm going to get started on the lecture. Hi everyone. Okay, so this is the Chapter 7 lecture. What we are actually going to do, we're going to split Chapter 7 into 2 parts. So we're going to do sections 1 and 2 together, and then we're going to have a separate test for those 2 sections. And then once we're done with that, then we're going to do section 7.3, and then 7.3 will have its own little quiz. Okay, so what we're finally going to get into, we're going to get into some math. So you definitely need your calculator and your periodic table out when you are going through this video. So what we are going to learn today is we are going to learn how we measure matter. We can measure matter in 3 different ways. One of the ways is by counting, okay? Another way is by measuring. And actually, we can count matter by looking at the mass and also by looking at the volume. So basically, I'm going to be teaching you 3 different conversions, okay? 3 different conversions that you are going to be using pretty much all of the time in chemistry, all right? So in chemistry, we do use a measuring unit called the mole. So you guys are finally learning about moles. Okay, so once again, a mole is just a measuring unit that we use in chemistry. And learning how to use all of these chemical conversions for chemistry is extremely, extremely important. You have to master this skill. You cannot survive this class without knowing how to do mole conversions. Okay? All right, so you might be wondering, what is a mole? And if you are familiar with Austin Powers, then you might have recognized this character from the movie. He's a mole and he has a giant mole on his face, right? Okay, well, this is actually not the type of mole that we are referring to. So once again, in chemistry, the mole that we are referring to is just a conversion, okay? It's a measuring unit. All right, a mole is a measuring unit used in chemistry. All right, so mole can be abbreviated MOL. For some reason, we just drop off that E because I guess sometimes it's just a pain in the butt to write that last E. So that is the abbreviation for mole. This number right here, 1 mole equals 6.02 times 10 to the 23rd representative particles, okay? That is the very first conversion that we're going to be learning, and this is referring to counting, okay? So representative particles can mean anything. It can mean an atom, a formula unit, an ion, a molecule, okay, any type of particle, all right? And this is known as Avogadro's number, all right? Avogadro's number. So please make sure that you have this number here memorized, okay? This number needs to be memorized. Now we're going to practice using that first conversion that I just talked about. The 1 mole equals 6.02 times 10 to the 23rd particles. So in this question, it's asking how many moles of magnesium is 1.25 times 10 to the 23rd atoms of magnesium, okay? So we're starting off with atoms, which is a particle. So that's how I know that we're going to be using Avogadro's number, all right? So always start off by writing the number that's in the problem. That's where we are starting. So 1.25 times 10 to the 23rd atoms magnesium, okay? Then I'm going to write a times sign, and I'm going to draw a line there. So then what I'm going to do is we're going to decide what number is going to go on top and what numbers go on the bottom. So we have to decide whether the 1 mole will go on the top here or on the bottom, or if the particle number will go on the bottom, or if that particle number will go on top, okay? So that's what we're trying to figure out. And you basically want to set it up so that your units cancel out, all right? So notice that this number here, Avogadro's number, represents any type of particle, okay? So we're starting off with atoms of magnesium. That is a particle. So then therefore, we're going to put particles, or the one that we're talking about in this problem has to be atoms. So we were going to put that on the bottom here so that these units would cross out. Okay, so it'll look like this. So then the 6.02 times 10 to the 23rd, and once again, this is going to be atoms, okay, because that is the particle that we're talking about in this problem. So I put that on the bottom, and then therefore, the 1 mole is going to go on top. Okay? And then you can see that it's just a conversion, converting the atoms here. Once again, the arrow got shifted. It should be right there. Atoms, we are converting those into moles. Okay? So you can see how we have this set up here. We have atoms. We put atoms on the bottom. So those are going to cancel out. So I can cross out the atoms. And then that's going to leave us with our answer in moles. And that is exactly what we are looking for. Because go back to the question. How many moles, okay, of magnesium is 1.25 times 10 to the 23rd atoms of magnesium? All right? So then the last thing that we do is we're going to put this into our calculator. All right, we're going to put this into our calculator. So you see the scientific notation here, times 10 to the 23rd. So it's been a while since we've done this in your calculator. Don't forget, that's where you use your exponent key, okay, where it says times 10. So once again here, also, you'll use your exponent key, okay? So on this side, when you see this conversion here, hold on, get a laser pointer. All right, so when you see this conversion factor here, remember, if this number is on the bottom, that means you're going to divide, okay? Since the 1 mole is on top, you're going to multiply. But since the number is only 1, you don't really need to put that into your calculator. So then just divide by the 6.02 times 10 to the 23rd, all right? So type that into your calculator, and if you do it correctly, you should get 2.08 times 10 to the negative 1, and then don't forget your units, moles of magnesium. Okay, now my answer is just in scientific notation, so don't forget that the -1 here, that just means to move your decimal one place to the left, all right? So if you put 0.208, that is also correct, all right? And you always need to make sure you go back and look at sig figs. So this number here has 3 sig figs, so you're going to keep 3 sig figs in your answer, all right? All right, now we have another sample problem. How many atoms, so that's our question, are in 2.12 moles of propane? And this is your chemical formula for propane. So we're basically going to convert the moles into molecules, and then we're going to break the molecules down into atoms, okay? So atoms are the representative particles that basically make up a molecule, all right? So let's start with the number that we're given, the 2.12 moles of C3H8. Okay, so we want to set this up so that our units cancel. So this time we are starting with moles, all right? So we're starting with moles here. So then therefore I have to figure out, am I going to put mole on the bottom or am I going to put mole on top? Okay, well, if we start off with moles here, then we know that that's going to go on the bottom of the next step. Okay, so then I'm going to put the 1 mole on the bottom. This time, Avogadro's number is going to go on top. 6.02 times 10 to the 23rd, and the particle we're starting out with is a molecule, okay, a molecule, all right, because C3H8, that is a molecular compound, therefore we call those particles molecules, all right? So you can see that the moles will cancel, and then so far that's going to leave our answer in molecules. But if you actually go back and read the question, it wants us to put our answer into atoms, not molecules. So in this particular problem, we have one extra step. We have to break down the propane molecule into its parts, okay? So we're going to do one more step here. Now this time, we have molecules on top. Therefore, to get that to cancel out, we want to put the molecule on the bottom, okay? So for every 1 molecule of propane, which is C3H8, we're going to do a ratio, okay? We're going to do a ratio. So in 1 molecule of C3H8, how many atoms are in that molecule? So think about that. How many atoms are in C3H8? Okay, how many atoms are in C3H8? Well, it would be 11. 11 atoms. So if you're trying to figure out how I got 11 by adding up the 3 carbons with the 8 hydrogens. Okay, so that's a total of 11 atoms in 1 molecule of C3H8. Okay, now, oops, pen option. Okay, so you can see there, then the molecules will cancel, and then that will leave us with our answer in atoms. And now we're going to put this into the calculator. All right, so if the number's on top, that means to multiply. If the number's on the bottom, that means to divide in your calculator. All right, so if you did this correctly, using your exponent key and everything correctly, you should get 1.40 times 10 to the 25th atoms. And once again, to figure out how many sig figs your answer should have, always refer back to the number that was provided in the problem. So that's the 2.12 moles. So that's 3 sig figs. That's why I kept 3 sig figs there. Don't forget that trailing zeros count if there is a decimal. All right, so this is the correct answer for that problem. If you're having trouble getting that correct answer into your calculator, please make sure you ask me for help during class so I can help you with your exponent key. Now we're going to learn another conversion factor, and this one involves molar mass. Okay, this term right here, molar mass. The mass in grams of 1 mole of substance. Okay, the mass of 1 mole of substance. So don't forget, 1 mole is equal to 6.02 times 10 to the 23rd particles. That's a huge number. Okay, don't forget, if you have a positive exponent, that means you're moving your decimal that many places to the right. Okay, so first I have to teach you how to find molar mass. All right, so you need your periodic table for this. So if you don't have it out yet, you should definitely get it out. So to look up the molar mass of a particular substance, you look it up on your periodic table. All the masses that you see on your periodic table, you're going to add all of those up for that particular substance. So this first example involves SO3. Okay, so if you look on your periodic table, find sulfur. Okay, so there's only 1 sulfur in that formula. So if you look it up on your periodic table, it's approximately 32.1 grams. Okay, then notice that there are 3 oxygens in that formula. So we're going to add up 3 oxygens. All right, so that's why there's a 3 there. Multiply that by the mass of oxygen that you find on the periodic table. Okay, so that's all you're doing. You're just adding them up from the periodic table, and then you get the total. So let me show you where I get those numbers on the periodic table if you're having trouble understanding where those came from. Okay, so here you can see oxygen. It's approximately, or it says on there, 16.00. All right, so that's where I got the oxygen number. And then you find sulfur, which is right underneath it, that says 32.07. So the 32.07, I just rounded to 32.1. And this is how we would write the molar mass. We would write it as 80.1 grams per mole. So in other words, that means if we have 1 mole of SO3, it's going to equal 80.1 grams. Okay, so let's also take this a step further. Well, how many particles are in 1 mole of SO3? Well, we just learned that 1 mole has 6.02 times 10 to the 23rd particles. So that means that 6.02 times 10 to the 23rd particles of SO3 will have a mass of 80 grams. Okay, that's what that all means. I mean, that's a lot of particles, all right? Now we're going to do a sample problem involving molar mass. Okay, so let's go to the next slide. All right, so this question, how many grams are in 9.45 moles of SO3? Okay, once again, this poor arrow got shifted. It should be right there. So we're converting the moles into grams. So anything with grams in it, we're going to use the periodic table. So the first thing you need to do is add this up from your periodic table. So it contains 2 nitrogens and 3 oxygens. Okay, so let's add those up. I already have all these numbers memorized because I use these numbers like all the time. So 2 nitrogen, so that's 2 times 14, so that's 28. And then oxygen, we have 3 of them, so 3 times 16. Do your math, what is that, 48? So if you add those up together, 8 plus 8, 16, carry the 1, 4, so 76, okay? So it's going to have a mass of 76 grams, and we call that grams per mole, all right? You can write it out like that, 76 grams per mole, or if it's easier for you, you can write out 1 mole equals 76 grams, all right? It means the same thing. All right, so now what we're going to do is set up our problem. Always start with the number that's given, so the 9.45 moles of N2O3. Draw our line. Now what we're going to try and figure out is what number should go on the bottom here, okay? Should we put the 1 mole on the bottom, or do we put the 76 grams on the bottom? So don't forget, we want to set it up so our units cancel. So if we start off with moles here, then we want moles on the bottom in the next step. So then therefore, the 1 mole goes on the bottom, and then the 76 grams will go on top. So you can see that the moles will cancel, and then that will give you your answer in grams, and that's what we were looking for. So since the number is on top, we're going to multiply, and then round your answer to the proper number sig figs. So then if you multiply that, you should end up getting 718 grams of N2O3. And that's it. So 3 sig figs there. That's why I kept 3 sig figs in the answer. Okay, we are finally on our last conversion, and this one has to deal with volume, okay? So this one is volume. So let's write that down. All right, so this is dealing with volume. So according to this, it says 1 mole of any gas occupies 22.4 liters at STP. So it tells you right here what STP means. STP stands for standard temperature and pressure. So those are the standard temperature and pressure values, 273 Kelvin or 101.3 kPa. So kilopascals, that is a pressure unit. Those numbers eventually will need to be memorized, okay? You're not really going to be tested on those numbers for this Chapter 7 test, but later on throughout the year, you will need to have those memorized. All right, so basically, what this is stating, it's stating that if I had 1 mole of, say, oxygen gas, it would occupy 22.4 liters. If I had even 1 mole of CO2, it would also occupy 22.4 liters, okay? So 1 mole of any gas at STP will have 22.4 liters, okay, or occupy 22.4 liters, all right? So if you want to write that out, it'll just look like this. 1 mole equals 22.4 liters, okay? That is our very, very last conversion. So now let's do a sample problem. Okay, so this is our very last sample problem. Once again, this poor little arrow should be right there. Determine the volume. So that's what we're trying to find in liters of 0.6 moles of SO2 for a gas, and it's at STP. Technically, we can only use that conversion for gases at STP. So that's why it's stating that in the problem. All right, so we're going to use our volume conversion. 1 mole equals 22.4 liters. Let's always start with the number that's in the problem, so the 0.6 moles. All right, and this is of SO2. Now we have to figure out what's going to go on the bottom here. Should I put the 1 mole on the bottom, or should I put the 22.4 liters on the bottom? Well, if we start off with moles here, we know we want that on the bottom of the next step. So then we put the 1 mole on the bottom. Therefore, the 22.4 liters will go on top. So you can see that the moles will cancel, and then that will give us our answer in liters. So then we just multiply because the number's on top, and we want to round our answer to have only 2 sig figs. So then in the end, you should get 13 liters of SO2. So you should practice putting that into your calculator all by yourself. Here's a diagram that we call the mole roadmap, and this basically summarizes all 3 of those conversions that you just learned, okay? So we have mole in the middle, all right? Mole in the middle, and then you have these 3 things branching off of it. So you can just use this diagram as a learning tool. So you're not going to be able to use it on a test, but while you're learning the conversions, it's helpful. And if you like to use this roadmap, you'll have to have it memorized if you want to use it on a test, okay? But once you practice these problems, you'll realize eventually you don't even need it. All right, so once again, mole in the middle, and then the three things branching off of it: mass, particles, volume. All right, so anything with mass, that means that you're going to use your periodic table, okay? So in other words, anything with grams in it, use the periodic table. Anything with particles, you're going to use Avogadro's number, okay? Anything with particles, use Avogadro's number. Anything involving volume, you're going to use 22.4 liters, okay? All of those conversions are equal to 1 mole, all right? They all equal 1 mole. So in other words, 1 mole equals so many grams. 1 mole equals 6.02 times 10 to the 23rd particles. 1 mole equals 22.4 liters, okay? And I don't know if you noticed, but this makes a heart, and you will realize that you will soon love moles. All right? So what we're going to do in class, we're going to practice doing lots of these math problems. So make sure you bring your calculator to class. Okay? Good night.